So today we are going to start to get more tools for actually designing the solution or planning the solution. So last week we learned how to use the data and the variables, and we learned how data is stored. This week we're going to learn how to use the operations that allow us to actually do the processing steps from the IPO diagram. Okay? And so we're actually going to learn how to solve the problems. Excuse me. So there's a couple different kinds of operations. One of them is the arithmetic operations, and we're going to look at those first. We're going to also look at, those include some things that you're familiar with, as well as one or two new ones. We're also going to look at being able to assign or save information. We're also going to look at the relational and logical operations. These all make up the algorithmic solutions. These are all the tools to make up the algorithmic solutions. And we're eventually going to learn how to repeat. We won't do that this week. Let's see. OK, so the very first operation that we're going to look at is the assignment operator. Did we look at that at all? We looked at it a little bit, right? No? OK. Sounds familiar to me. OK. So the very first operation we're going to look at is called the assignment operator. And this looks a little different than what you may have been used to in math. Okay? We're going to use the single equal sign, which represents the assignment operator. Now, the assumption is that all our data has previously been declared. Okay? So we know what happens when we declare data. What happens when we declare data? Space is allocated in memory. Okay? So now what we'd like to be able to do is assign values to this data that we've allocated. Now, what I want you to look at with the assignment operator is look at this notation right here. So when we use the assignment operator, what takes place, what has to be on the left-hand side? A variable, only a variable. Okay? So one single variable goes on the left-hand side of the assignment operator. Okay? So this assignment operator is not the same thing as equals. Okay? Assignment and equality are different. Assignment and equality are different, and we're going to look at that today. Okay? So for the beginning, we're going to talk about using assignment. All right? So if I use, where's my eraser? If I declare a variable such as int x, we know that what happens? Space is allocated in memory for x. Okay? If I now say x equals 3, and we always follow that with a semicolon, what is this operator right here? Assignment. And this guy is a variable, and this guy is a constant. It's actually a constant number. Okay? So what happens when I say x equals 3 in that expression as I'm doing right there? What happens in that expression? Ideas? What happens when I use assignment and I say 3 is assigned to x? Nobody? Okay, well, x is in memory at this point in time. Okay? So what's going to happen is that the 3 will get in the memory location, which we know is actually a 1, 1, but we're not going to do binary anymore because we know how to do binary. So I'm just going to put a 3 here, and everybody's going to assume that by that, the understanding is that the binary equivalent of 3 is there. But 3 gets stored at the memory location called x. Okay? So this guy right here is assignment. So if right now I did cout x, what would be displayed? 3, because x now has the value 3. Does everybody see that? So the single equal sign is the assignment operator. Now, the right-hand side, so the left-hand side can be any variable. So if I did something like Okay? So if this is a variable, okay, it would have to exist in memory. And what happens when I assign 5 to that variable? The value 5 gets stored at the memory location called num people late. Okay? Now, it doesn't just have to be one single variable. What can actually go on the right-hand side? Some type of expression. Some type of expression. So the expression may actually have a mathematical formula in it. So, for example, we may say, let's say that I declare x and I declare y. That means their space is allocated in memory. And if I now say x equals 5, what happens when I say x equals 5? Can you guys see there? What happens when I say x equals 5? X equals 5 right here. Now, what happens if I say y equals x? Start at the right. So x has what? 5. So what does y get? 5. So they don't point to anything the same. I just take whatever's in x and assign that to y. Okay? All right, so it can be various types of expressions. So let's look at some of the possibilities that we could have here. All right, so first of all, understand that when you're doing assignment, you start at the right-hand side of the equation. So whenever, in this example right down here, I start at the right-hand side value of the expression. This guy is a variable with the value 5, and then I assign that value to y. Okay? So whenever I use assignment, I start at the right, evaluate, and then take that value and put it into the variable on the left. Does that make sense? So start at the right, evaluate, put that value into the variable on the left. Okay? What's wrong with this? So let's say I have a variable called stamp. So stamp has a memory location. And if I say stamp equals 14, this is fine. What happens when I do that? 14 goes into stamp. Okay? What happens if I do this? Okay, I feel like we're not all with me here. Okay, so hold on. Okay, so let me put this over here to make sure everybody can see. I'm going to put on both sides. Stamp equals 14 is fine. Oops, it's supposed to be stamp. Because stamp got the value 14. What is wrong with this? So the only thing that can go on the left of an assignment statement is what? A variable. And 14 is not a variable. On the other hand, what is 14? It's a constant. We cannot change 14. So this is invalid. Because if we go back and look, the only thing that can go on the left is a variable. One single variable. Does that make sense? Okay. What about this guy right here? What's wrong with this guy? There's two variables and an operator. This guy is actually what we would call what? An expression. This is actually what we would call an expression. So we cannot have an expression on the left-hand side. This is perfectly fine, okay? But the only thing that can go on the left-hand side is a variable that's been declared. Does that make sense? So we're rethinking, when we do programming, we don't use that, we use that equality sign, but it works very differently. It works as an assignment operation. Okay. So let's say we have the following variables. I'm going to put the slide up so that we can all see from all corners of the room. I think we can see it on the back. Okay, so given the following declarations, okay, what happens when I declare a variable? Space is allocated in memory. So I have space for stuff. Okay, when it's an integer, what does that mean again? It's a whole number. It's a whole number, okay? What's a string? What's a string type indicate? A bunch of characters, right? Okay, and then I have widget and num-widget. So here's what my memory looks like right now based on the declarations. First thing I'm going to do is I'm going to say num-widgets equals 10. So what happens in that first expression? What happens in that first expression? So, who's talking? Raise your hand so I can. Who's? Okay, wait a second. Where's your? I can't see your slide. No, your name sheet. She's hiding. Teresa. Okay, so Teresa and Anika and Alika. Okay, so what happens when I say num-widgets equals 10? Yes, so num-widgets gets the value 10, and we know in actuality what would be stored there? The binary equivalent of 10, correct. Okay? All right, step number 2. Now, this is a little different. Num-widgets equals num-widgets plus 1. Now, which side did I say to start on? The right-hand side. So let's look at num-widgets plus 1. What's num-widgets? 10. What's 10 plus 1? 11. So what does num-widgets get? So this guy changes to 11. Now this particular operation is actually pretty important. When we add 1 to a value, come over here. When we add 1 to a value, we call that an increment. Why is adding 1 an important operation? Why is adding 1 an important operation? Tyler? Typically, when I'm counting, I add 1. So this is going to be a very common thing to do. C++ actually has a special way of doing this, and I'll show you that when we get to addition. Okay? All right, let's look at the third step here. Name equals Toby. So what happens when I say name equals Toby? Okay, so Toby gets stored how? ASCII. So what would be stored there is the ASCII equivalent of T, which you can look up in your chart, the ASCII equivalent of O, which you can look up in your chart. We don't have to do this. I just want you to understand how this typically, as a programmer, you're not caring so long as you understand, okay? And the ASCII equivalent of Y. So how much storage does Toby take up? 4 bytes, because each ASCII character takes up 1 byte. Okay. All right, let's take this next expression here. Stuff equals num-widgets. Stuff equals num-widgets. What happens? We start at the right. Num-widgets is 11, so stuff gets 11. Okay, good. All right, and then one more. Widget equals num-widgets times 2. So widget gets, okay. Does everybody follow that? Question? See? Where do I say 30? Huh. Oh my goodness, place the value 30, and where in the world, I must have changed the number somewhere. Num-widgets is 10, becomes 11. Yeah, I need to correct that. Let's see if I can. Thank you. I don't know where that, something must have changed along the way. Okay. All right, so The good news is about this, like I always tell you, we know a lot of this stuff already, okay? These symbols should look mostly familiar to you, all right? So we have the addition symbol, which we're going to talk about, subtraction, multiplication, division. I see we don't actually have a symbol for exponentiation in C++, but we're going to talk about it just because of it's an important operation. And we have one new operator, okay? So let's look at these different operators.